and today we are going to look at a simulation of the window comparator. So we have two op amps, op amp U1 and op amp U2, and we're just going to simple LEDs for the output, which will indicate the state of the comparators. VIN, this is from our input transducer, pressure sensor or temperature, what have you, is we're going to control by moving this wiper on the potentiometer, and that's going to go, VIN is going to go to the non-inverting input on U1 and the inverting input on U2. The two reference voltages, LTP, the lower trip or trigger point, is formed by this resistor network R3 and R4, okay, and it's at 1.56 volts. And then the upper trip or trigger point is being composed by the network R1 and R2, and it's at 3.75 volts. Okay, so what we're going to do is I'm going to turn on the simulation, and I'm going to change the VIN here. I'm going to change it so that we start all the way down to 0. Okay, sorry, it's a little bit of a lag in the simulation, but there we go. Okay, so it's saying VIN is 1 microvolt, which we'll just agree is 0. Okay, so if we look at the LTP here, we can see then we have essentially 0 volts on VIN, but our reference voltage, our LTP, is fixed at 1.56. Okay, so this does not change, right? This changes. Okay. So right now we have a situation whereby the voltage at the non-inverting, the plus input, exceeds the voltage at the inverting input. So the voltage, the reference voltage, LTP, is greater than VIN. So therefore, the output of the comparator is at positive Vsat, which is enough to forward bias this LED, which is why it's on. If we go to the upper comparator, right, we can see then that the voltage at VIN, again, is 0. The voltage at the negative input is at 3.75. So the voltage here at the inverting input exceeds the voltage at the non-inverting input. So therefore, this is at minus Vsat, which is reverse biasing LED 1, so it's off. Okay. So let's now go and increase the input voltage. I'm going to set it as close as I can to this. So I'm just going to increase. Okay. I won't do it too far. Okay, so at 1.2 volts, okay, this is still at 1.56. Again, this is fixed. So we're still in the situation, the same one that we started off in, whereby the voltage here exceeds the voltage here. So this is at positive Vsat. So the light is still on. Okay. Now, because the coarseness of this adjustment, I'm not going to get it quite as fine as I would like, but anyway, you'll still see. So I'm just going to go up another little bit. And okay, now we're at 1.8 volts. So now we have a situation where VIN exceeds the reference voltage. So the voltage here exceeds the voltage here. So therefore, because the inverting input has the higher voltage, this is at minus Vsat, and the LED 2 is off. Okay, nothing's changed up here. The voltage here, which is the 3.75, is greater than the voltage here, which is the 1.8. So this is at minus Vsat. So right now, if you can imagine, we're within the quotation marks window. Okay, so in this case, both LEDs are off. Okay, so we're just going to continue to go up. And going to try to get as close to this as possible. Okay. Okay, now the input is at 4.2 volts. Okay, so this is greater than this, so the potential here exceeds the potential here, so this is going to drive U1 output to positive VSAT, and voila, LED 1 is on. So the way it's set up, and you can compare this with, I have another slideshow presentation with some little different comparator circuits, but they all work basically the same. But in this case, LED 1 is on when the input voltage Vin is slightly greater than the upper trigger point, and LTP will come on, LED will come on when Vin drops below the trigger point. Okay, you could easily have it so the lights are on when it's within the window, right? In this case, the lights are on when it goes outside one of the trip points. It's all application driven. Okay, if you continue to raise Vin, and you can see then, right, we can raise Vin all the way up to its maximum, which is going to be essentially 12 volts. Okay, nothing has changed because this voltage here still exceeds that, so therefore this is that positive VSAT. Okay, so if I grab the slider, pick it up, oops, and it's a bit of a trick. I'll just do it this way then. Fine. Okay, I'll just bring the voltage back down, and then watch here. As soon as Vin goes below 3.75, then the light will go back off. Now in the lab, you're going to have, because this is a simulation, in the lab, you're going to have much finer control, but it'll work exactly the same way. Okay. What I haven't included here that we strongly recommend you do is the decoupling capacitors or demodulation capacitors from the DC bias pins on the op amp to ground. I haven't shown them here, but you're definitely going to want to include them. Okay, so now we're down to 3.6 volts. So we're just a little bit below the threshold. This LED is back off again. Okay, so we're within the window. And if we're just going to continue to drop the voltage, and as soon as we get below the LTP, okay, boom, there we go. Then this one comes back on again. Okay, so anyway, I hope that helps to clarify in your mind how the window comparator works. Very common in industry. Don't be afraid of it. It looks a little complicated, but in reality, it's a very simple circuit. And I hope it was beneficial to you. Okay, thanks. Bye. Have a nice day.